Welcome to Bald Guy DIY. In this video, I'm going to show you how to properly connect three-way switches. I remember the first time I wired a three-way switch, or tried to, and I was about 14 years old. My uncle had done some wiring, and he asked me if I thought I could connect it up. Well, I looked at it, and there were only 5 wires in the box, so I figured how hard could it be? And through process of elimination, I tried to go one by one and figure out which way it was supposed to be wired. Eventually, I got tired of it not working and gave up. In this video, I'm going to explain how to connect three-way switches in a couple of different configurations, and I'll have you connecting switches like a pro in no time. Now, three-way switches look a lot like regular switches. This is the Decorator or Decora style, but from the front they look the same. If you turn them over and look at the back, what you see is a regular switch only has 2 terminals, or a single pole that's being switched. When you snap the switch, it either closes the connection between those two and the light turns on, or it opens it and the light turns off. A three-way switch is different because instead of 2 terminals, it has 3. And instead of simply opening or closing a circuit, what it actually does is act like a switcher on a railroad track, and it actually switches between paths. When you click the switch in one direction, it connects the common terminal, the black one, to one of the terminals and opens the connection to the other one. And when you snap the switch in the other direction, it opens the connection between those ones and connects the common to the other terminal. This rocker action is simply switching between paths, and that is what makes it different from a regular switch. Because it's switching between paths, the one on the other end, if it switches to the same path, will turn on, or if it opens and switches to the other path, it will turn off. In any three-way switch circuit, the common terminal is going to be the black, and the travelers, or the 2 switching paths, are the other 2 gold or brass colored screws. That's going to be the same for any three-way switching circuit, and it's going to also be noted by the red and the black wires being the traveler wires in any three-way switching application. If you see them hooked up any other way than that, it's been done incorrectly. The red goes to one of the brass screws, the black goes to the other brass screw, and the common one is the one that's going to change depending on how we have our circuit configured. Let's take a look at what those options are. In the first option for connecting a three-way switch, we have the incoming power on a 14-2 cable, the 3-wire connected in a 14-3 cable, and then the outgoing power in the other device box in a 14-2 cable. Now, the red and the black, as I mentioned, are always going to be your travelers. So I'm going to mark those with a T here, and that'll show you those are going to be the travelers. It doesn't matter which one you connect to which brass terminal on the three-way switch, it's going to work correctly. On this circuit, we're also just going to join the 2 white wires together using a wire connector of some type. Whether you use morettes, wire connectors, push terminals, whatever you use, on both ends you're going to connect the white wire, which is going to allow the identified conductor to be connected all the way through the circuit. Lastly, as you can see, we take the common terminal, the black one on the three-way switch, and we connect it to the black wire of the incoming power, which is going to allow that to be switched between the 2 travelers. And we're going to put the common on the other three-way switch, which is going to allow the power out from the travelers and into our device on the other end. Once again, we're going to have the travelers marked here by T, and on the other three-way switch, you're going to connect it the same way with the travelers connected to the brass screws. Second way of connecting the three-way switch is to have both the incoming power, a 14-2 cable, and the outgoing power 14-2 cable in the same device box. And then the 3-wire cable with the red, black, and white going to the other device box by itself. This might look more complicated, but it's really quite simple as well. The first thing to note is, again, the traveler wires connected to the brass terminals of the three-way switch are the black and red from the 3-wire cable. This is going to be the same on every 3-wire connection you do. So on both ends, you can connect the red and black to the brass colored terminals on the three-way switches. The second thing to note is because they're in the same box, we can connect the white wire from the incoming power to the white wire on the outgoing power off to the device. That's going to make sure the identified connectors are connected again. Use an appropriate wire connector, wire nut, moret, push terminal, whatever works in your area. The last thing we have to do is connect the black wire from the incoming power to the white wire on the 3-wire cable. That is going to be the power that transfers over to the other device box so that you can connect it to the common of the 3-way switch on that end. Now the common is now going to feed through the traveler wires on the way back to the first 3-way switch, and that's going to be where the power comes in on one of those travelers, and then it gets routed to the common terminal, and that common terminal is now going to feed the load. It's as easy as that. I hope that demystifies 3-way switches and how they're connected. It really is that simple, and those are the only 2 configurations that you can have. If you find one that seems different than that, it's probably just the mirror of what you're looking at in these 2 configurations. Of course, you want to make sure that you're not working with the circuit live, so turn off the breaker that supplies that switch once you've identified which set of cables is the incoming power. Also, be sure to check with your local regulations in case there's particulars about how the bonding conductor should be connected. In the Canadian Electrical Code, you don't have to ground or bond your switches, but in the NEC or National Electrical Code in the United States, you do need to. So make sure you know what regulations are required. Until next time, I hope this inspires you to try something a little different that you haven't been willing to before and brings a little clarity to the whole situation. If you like these videos and you find them helpful, let us know in the comments or give us a suggestion for another video. Tell your friends and family, and be sure to check back every week as we post a new video. Until next time, in all your DIY endeavors, don't be afraid to be bolder.